So today we're going to talk about the angular momentum quantum number L. So when you see that in parentheses, that is supposed to be a lowercase l. So L begins at 0 and is also an integer value, 1, 2, 3, all the way to n minus 1. So it says the values of L are defined by n. This is mostly because L can only be as high as n minus 1. So this is the part where quantum numbers start to get a little bit tricky, only because they're dependent on other values. So the total number of values of L depends completely on n. The other thing with L is that just as we talked about n being a shell, L is the subshell. So you have a shell of n, but you have subshells, or kind of individual little parts of the shell defined by L. The subshells not only have numbers, so an L of 1, an L of 2, an L of 0, but they also have letters that go along with this. And so when you have L is equal to 0, that's actually an S subshell. When L is equal to 1, that's actually a P subshell. When L is equal to 2, it's actually a D subshell, and so on and so forth. You'll also notice that there are shapes associated with this. So as N actually told us something about size, L will tell us something about shape. And again, this is talking about this idea of shells and subshells. So what we can do is by defining N and L, we can actually talk about a specific subshell. And you'll notice this is also going to go back to electron configuration. Realize that in one electron systems, subshells have the same energy. Now in multi-electron systems, your subshells actually have different energies. So P is greater than S, D is greater than P, F is greater than D. You can also see in this little table that as your value of n increases, the number of values you have for L also increases. Let me say that one again. So if we had, for example, an n of equal to 3, L would be equal to 0 and 1 and 2. So when you have an n equals 3, you actually have 3 unique subshells inside of your shell n equal 3. So when n equals 3, you actually have 3 different values of L, 0 and 1 and 2. So in this way, n actually becomes the number of subshells in a multi-electron atom. So not just the number of the energy level number, but actually it relates to the number of subshells that you have. So all this idea of subshells you can actually see on the periodic table itself. So when you have an L equal to 0, that is going to be your S subshell, which you can see here in orange. When you have your L equal to 1, that's going to be a P subshell, which you can see here in blue. L equal to 2 is going to be your D subshell, here in the middle in gray, and your L equal to 3 will be your F subshell down here at the bottom. So in this way, realize that even though we're talking about quantum numbers and it seems very disconnected from everything else, that we are still trying to describe where electrons are, and that still relates back to the periodic table. So even after all of these things that we've done, talking about N and L and shells and subshells, we are still talking about things that relate to the periodic table.